Hello friends, this is the 8th video of Data Science playlist. In this video, we will learn about K-means clustering. K-means clustering is a popular unsupervised machine learning algorithm used to partition a dataset into distinct, non-overlapping groups or clusters. The algorithm aims to minimize the variance within each cluster while maximizing the variance between clusters. Steps of K-means clustering. First is initialization. Choose the number between cluster K in advance. Randomly select K data points as the initial centroids. Second is assignment step. Assignment step. For each data point, calculate its distance to all K centroids commonly used in Euclidean distance. Third is update step. Recalculate the centroids of each cluster. The new centroid is mean of all assigned to the dead cluster. Fourth, repeat. Repeat the assignment, update the steps until the centroid is no longer significantly change or predefine the number of iterations is reached. Key points. K is the number of clusters to form. This is the hyperparameter you need to define before running the algorithm. Distance metric. Typically, Euclidean distance is used, but other metrics can be employed based on data's nature. Convergence. An algorithm stops when the assignment is no longer changed, meaning the centroids have stabilized. Pros of K-means: simple and efficient for large datasets, works well with when clusters are spherical and evenly sized. Cons of K-means: the number of clusters K needs to be chosen in advance, which can be difficult without domain knowledge. Sensitive to initial centroid placement. Assumed clusters are roughly equal size density, which may not be true. So we'll move to the next slide, that is Introduction to clustering. First is unsupervised learning. Clustering algorithm learn patterns in data without labeled examples. Second is grouping similar data. Data points within the cluster share common characteristic, differentiating them from other clusters. Third is discovering hidden structures. Clustering reveals underlying structures and relationships with data. Fourth is applications in various fields. Clustering has application in customer segmentation, image analysis, and more. What is K-means clustering? First, there are four steps. First is initialization. Randomly select K data points as initial cluster center. Second is assignment step. Assign each data point to closest cluster center based on distance. Third is update step. Recalculate cluster center as a mean of all points assigned to that cluster. Fourth, repeat second and third. Assumptions and limitation of K-means. Assumptions are data is continuous, clusters are spherical, clusters have similar sizes. Limitations are sensitive to initial cluster center, may struggle with non-spherical clusters, susceptible to outliers. Steps in implementing K-means clustering. First is load prepare data. Import the dataset, handle any missing values or data transformation. Second is choose the number of cluster. Determine the optimal number of clusters using method like elbow method or silhouette analysis. Run K-means algorithm. Use a K-means function in R or Python to execute the algorithm and obtain cluster assignments. Next is visualize and interpret results. Create a visualization to understand the cluster structure and draw meaningful conclusions from the results. Next is visualizing cluster in R and Python. Scatter plots. Visualize cluster in two-dimensional space. Heat maps. Show cluster membership using color gradients. Dendrograms. Illustrate hierarchical clustering relationships. Evaluating cluster quality. First metric is silhouette store. Silhouette store means measures how well data points are clustered. Within cluster sum square WCSS, measure the sum of square distances from each point to each cluster center. Next is determining optimal number of clusters. Elbow method. Plot WSS against number of clusters looking for elbow point where decrease in WSS start level 2. Silhouette analysis. Calculate the silhouette score for different number of clusters seeking the average highest silhouette score. Next is real world application of K-means clustering. Customer segmentation. Customer groups into distinct segments based on behavior their purchase. Second is image compression. Image compression compressed image by grouping similar pixels together. Third is anomaly detection. Identify unusual data points that deviate from normal customer patterns. So the conclusion of K-means clustering is valuable tool for discovering patterns and grouping data means into meaningful clusters. It has wide-ranging application in various fields, understanding its assumption limitation and allows free use, effective and interpretation of the result. So friends, if you like the video, please hit the like button, share this video, subscribe this channel. Thanks for watching.